Okay, now we can start. Okay, so yeah, today we're going to talk about more general infinite series. That's the plan. Does anybody have any logistical questions about the write-ups or anything? I mean, there's a bunch of stuff now on the website. Tells you about like what I'm expecting and what I'm looking for. And I should post the Gradescope thing also. It's due officially Friday at 5 p.m., but like I also said, I'll give the weekend grace period if you want to take more time. But yeah, okay. All right, but if we're thinking about infinite series today, so the thing I wanted to talk about, so it's sort of strange that we start with geometric series because it actually primes you a little bit in the wrong direction because they're so nice, you can actually add them up. It's not true in general for infinite series that you can add them up. In fact, they're very mysterious a lot of times. Even if we can tell they converge, they're often very mysterious. So almost all the time, well, actually, let me just say this first. So remember, this is something like, a series is something like an infinite sum, n equals like 1 to infinity of some a sub n. So that's the thing also that's come up in office hours I've already seen, is that like, make sure you know the difference between a sequence and a series, because a sequence is just a list of numbers, but a series is like adding up a list of numbers, right? So like, we've seen a bunch of these. You know, for example, we had something like, a very simple example we had was something like this, which is a half plus a quarter plus an eighth plus a 16th plus so on. So notice that's a series versus you could have a sequence, the sequence like 1/2, comma 1/4, comma 1/8, comma 1/16, and so on, right? So just the words are used very specifically, even though like series and sequence might be kind of like colloquially have a similar meaning to you, you know, like in the real world. This is, I think of like sequences with commas and series have plus signs, right? And here, like you can say like the limit of a sequence is not that hard often. It's like, that's something that's pretty easy to find. Whereas here we actually had to do some work to find the sum of this. Like what is this sum? And we'd have the sort of there's the partial sums. So maybe I'll write it in general here and then in the specific example. The partial sums is where you stop somewhere. I mean, it's a really natural thing. It's like when we think about infinite series, we don't actually think about infinitely many terms. We actually usually just stop somewhere, right? And for example, here we could have the sum from 1 to k of a half to the n. That's a half plus a quarter plus an eighth. But now instead of having the plus dot 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 forever, we have a dot 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 plus maybe a half to the k minus 1 and then a half to the k, right? And then by definition, like this is really the definition of an infinite series, is that it's the limit of its partial sums. So by definition, an infinite series is the limit of its partial sums. It's sort of saying, like, if you want to think about adding infinitely many things together, you think about adding finitely many things together and then keep going and keep going and keep going. So in some ways, there's like two sequences associated with, like something like this series right here, the 1/2 plus a quarter plus an eighth series. There's the sequence of terms, a half, comma, a quarter, comma, an eighth, comma, a 16th. But there's also the sequence of partial sums, which would be like a half, comma, a half plus a quarter, comma, a half plus a quarter plus an eighth, comma, a half plus a quarter plus an eighth plus 16th, and so on. So So, right, so here, like, right, maybe I should just write that over here. Like, if we actually listed partial sums here, S1 would be a half, S2 would be a half plus a quarter, S3 would be a half plus a quarter plus an eighth, S4, quarter plus an eighth plus a 16th, and so on. So right, so there's like two sequences associated to a series. Maybe I'll just write over here. There's the sequence of terms. Like if we have like, right, if we have, maybe I should say a series, the sum of a sub n equals 1 to infinity. We have the sequence of terms, a sub 1, a sub 2, a sub 3, a sub 4. That's like that sequence I wrote up there, right? Versus the sequence of partial sums. So that would be like a sub 1, comma, a sub 1 plus a sub 2, comma, a sub 1 plus a sub 2 plus a sub 3, which is really s sub 1, s sub 2, s sub 3. Right, that's the same thing. Does that make sense? Yeah, Alicia. No, that's good. I wonder if I clicked on the wrong meeting. Yep, I went to my personal meeting room instead of the, oh man, okay, thank you.